What is a galaxy? Until the 1920s, we only knew of our own galaxy, the Milky Way. Even with telescopes, we could barely see little fuzzy spiral shapes in the sky, and we wondered what exactly they were. Dusty nebulas? Or other galaxies entirely? There was a great debate about the issue. Ultimately, Henrietta Swan Leavitt's work on distances to stars enabled Edwin Hubble to prove that the largest fuzzy spiral shape in the sky was actually a galaxy entirely separate from our own, the Andromeda Galaxy. So cool! It was the beginning of our discovering and grasping the vastness of space. Since Andromeda, we've learned there are billions more galaxies outside of the Milky Way. Galaxies are concentrations of stars, gas, dust, and dark matter, all held together by gravity. Many galaxies are spiral galaxies, like the Milky Way, but there are also elliptical and irregular galaxies. As far as we know, all large galaxies have a supermassive black hole at their centers. We also know that galaxies interact with each other, creating beautiful new forms over millions of years. This is true for Andromeda and the Milky Way, too. Our galaxy is on a collision course with our nearest neighbor. While that may seem violent to you and me, galaxies are so huge that most stars will pass right by each other. Phew! Eventually, the Milky Way and Andromeda will merge into one giant new elliptical galaxy. It's not for another several billion years, but it's sure to be a spectacular show for the stargazers of the distant future.
What happens when galaxies collide? With billions of galaxies in our universe, it's no surprise that they sometimes collide. The Milky Way and its nearest similarly sized neighbor, Andromeda or M31, are part of the local group of galaxies. They're pretty close to each other. Only about 10 galaxy links separate the Milky Way and Andromeda. And when they collide in 4 billion years, it will be spectacular. We can simulate the collision of the Milky Way and Andromeda galaxies and predict that it should lead to a great deal of new stars and a whole lot of galactic chaos. Eventually, the two galaxies will merge into a single galaxy, which will settle down into a larger Milkdromeda galaxy. But don't worry, the stars within the galaxies won't collide. Galaxies are made up of mostly empty space, and the stars within them are very spread out. But the gas that surrounds the stars and forms them will collide spectacularly. Many galaxies are in the middle of a collision today. These type of galaxies are the ones that would not have fit into Edwin Hubble's categories. Irregularly shaped spirals, merging and distorting arms winding in strangely beautiful shapes. The exquisite detail of these types of collisions can be studied in a new light with NASA's James Webb Space Telescope.
How is gravity like nature's magnifying glass? To find out what the universe was like in the beginning, we need to study the most distant galaxies, whose light has been traveling to us for billions of years. But the farther away a galaxy is, the fainter it appears. That makes distant galaxies very hard to see, even for the most powerful telescopes, because they can only collect so much light. Fortunately, nature can provide a helping hand. According to Einstein, the gravity of massive objects can be so intense that it can warp the fabric of space-time. Light, which normally travels in a straight line through space, can show us where this distortion occurs. a very massive object will warp space and bend the path of the light. In a sense, warped space acts like a magnifying glass. A magnifying glass collects and bends light, making a light bulb, for example, appear bigger and brighter. Warped space can do the same thing to light from a galaxy. So what acts like the biggest magnifying glass in space? Galaxy clusters are the most massive things in the universe with the most gravity. When light from a very distant galaxy passes through a cluster, it is amplified and distorted, with the cluster acting like an imperfect magnifying glass. Light that would have gone in other directions gets bent toward our telescope. That lets us see the very distant galaxy in more detail. This effect is called gravitational lensing. Without this natural boost from gravity, it would be impossible for our telescopes to see far away enough in space and time to study galaxies in the early universe. The Hubble Space Telescope has made use of gravitational lensing to see many distant galaxies. And the larger James Webb Space Telescope will be able to find galaxies even fainter and farther than we've ever seen. With Webb, we will look for the very first galaxies to form and really learn about the early universe.